Okay, the final lesson in this unit is on interpreting graphs. So in other words, we're going to go a little step further. I'm not just going to look at the graphs and give some specific things. We're actually going to try to say, well, what do those things mean? Okay. And my experience tells me this is usually the place where the answers aren't very well done. So spend some time doing the homework on this lesson. Make sure you understand what you're supposed to be looking for. Okay, where does the graph intersect the vertical axis? Vertical axis, that's right up here. It intersects it at the point 0, 1,000. All right, we call this the initial value. Remember that B value? Okay, the initial value is 1,000 meters. What does it represent? All right, this is the height when time is 0. It's the starting point. When we start at 0 minutes, right there, the height is 1,000. Whatever this is talking about, in this case, it's a float plane. When we start timing, the plane is at 1,000 meters high. Okay. Where does the graph intersect the horizontal axis? At the point 10, 0. Okay, what does that mean? This means after 10 minutes that we're timing, after 10 minutes, the plane has a height of 0 meters. Now you could say the plane is landed. That would make sense to me. Okay, what is the rate of change for this graph? Remember, rate of change is the change in y over the change in x. Okay, so how much has the y changed? How much have we gone down and how much have we gone for x? That's what we're looking for here. Well, let's take this point, 0, 1,000, and let's take this point, 10, 0. And what's my change in y? 1,000 take away 0. What's my change in x? 0 take away 10. This is going to be negative 100, what? Meters per minute. How do I know what the what is? Okay, it's the y over the x. Why is the rate of change negative? The height is decreasing. Okay, so that's the kind of question you're going to get for sure. Matter of fact, a lot of times the test is even a question identical to that. Okay, the point where the graph intersects the horizontal axis has the coordinates. We had 10, 0. This point is called the horizontal intercept. Okay, you are going to start seeing the term x-intercept. That's the language we're going to use from now on. Okay, the point 0, 1,000, that was called the initial amount. Okay, we're going to call this the y-intercept or the vertical intercept. Okay, try another one. Determining intercepts, domain, range, and graph of a linear function. So we have a linear function. Man, the graph even looks the same. It's this red line that's going down. Okay, write the coordinates of the points where the graph intersects the axis. This is 0, 8, and this is 200, 0. So let's write that, 0, 8, 200, 0. Okay, that's the coordinates. Determine the vertical and horizontal intercepts. Okay, now vertical intercept, we call that the y-intercept. Y-intercept is 8. The x-intercept is 200. Notice that it's just one number, it's not a point. Describe what the points of intersection represent. Okay, so this is gas in a scooter, and we could say the initial amount at the start, or at the initial amount at the start, there is 8 liters of gas. Or when time is 0, or sorry, when distance is 0, there's 8 liters of gas in the tank. Okay, what does the x-intercept mean? After 200 kilometers, there is no more gas. Tank is empty. We've run out of gas. Okay. Domain and range. Well, the domain is continuous, so I got to say from 0 to 200. The range, and I know you might want to say 8 down to 0, but it's from 0 to 8. Okay. Matching a graph to a given rate of change. Okay, this is a real quick question. It says the rate of change is a half, and it has a vertical intercept of 6. Well, you can see these both have a vertical intercept of 6. So which one has a rate of change of a half? Well, hopefully you say it's got to be this one, because this one has a positive rate of change. This one is actually negative over here. So it's definitely not that one. Okay. I'm going to skip this. I'll come back to it. Let's do example 4, and then I'll do example 3 in a separate video lesson. Okay, this graph shows the cost of publishing a school yearbook. The budget for publishing costs is $4,200. What's the maximum number of books that can be printed? So we're looking for 4,200. So this is 0 books cost this much, 50 books cost this much, etc. We want to know how much we could make with $4,200. It's about here. Okay. Now, should I connect this? Hopefully you say no, because I can't have partial yearbooks. But I'm going to leave it connected just for this question, and then I'll erase it. Okay. $4,200 would take us to about right there on the line. And that, to me, looks like it would be approximately, a bit more than 175. So I'm going to say approximately 180 yearbooks. Looks like I could have 180 yearbooks for $4,200. Now, that's just an estimate. We'll see if we're accurate as we get going with this question. Okay, that's using the graph to estimate. Okay, so I showed you what that looks like. We drew a little diagram. Method number 2 says create a function. So this time we're going to make a rule and then figure it out that way. Okay, to make a rule, since it's linear, I'm going to use my linear formula. Y is going to be the rate of change times x plus the initial amount. Now the initial amount's easy to figure out. It's 500. Okay, I can see here this is 500. All right, the question is, what is the rate of change? How much has it gone up? Okay, to do this, pick any 2 points. Okay, I'm going to pick these 2 points. This one up here is 100, 2,500. And this next one is 50, 1,500. Okay, if I pick those 2 points, I can figure out the rate of change. 2,500 take away 1,500 over 100 take away 50. Okay, and that looks like I'm going to get $20 per book. Okay, so we'll put 20 here. Now, if that's my equation, I could get fancier and I could say the cost is 20n plus 500. It doesn't matter. Okay, and the question is saying, if I have $4,200, how many books could I buy? So doing your algebra, if I take away the 500, now I'm going to divide by 20, and I get 185 books. Which one do you think is more accurate, 180 books or 185 books? Hopefully it makes sense that this is more accurate because you've actually used the formula we figured out. Okay, we're almost done. Exercise 31, and then we'll do the last lesson tomorrow.